Welcome to ePathshala lecture series in computer science. This is a course in cloud computing. Today we are going to continue our discussion on virtualization. So, the learning objectives of today's class will be, we will first look at what is virtualization layer, and then we will see what are the different types of virtualization, and we will look at virtual machine and see what are the fundamental properties of a virtual machine and the different types of virtual machines, followed by summary. In the last class, we started the discussion on virtualization, where we saw an example of library and we looked at the goals of virtualization. So, this class we continue and understand the types of virtualization, types of VMM, types of virtual machines, and the properties of virtual machines. So, virtualization is the concept of creating a virtual environment, an environment that exactly behaves like a hardware environment. Therefore, physical environment, any physical environment can be virtualized. In this list, we can first talk about the host machine, the hardware of the machine where the virtualization. Besides that, everything in fact can be virtualized, and we in this module we will look at what are the other possibilities. So, let us look at the types of virtualization. The first one, as we said, is the machine level virtualization, which is the physical machine where the computer is running, that is processor, memory and all other objects that are there in the physical machine. Then comes the network virtualization, which is virtualizing the network. Then comes the storage virtualization. Since storage is a separate and a very important part of machine, we would talk about storage virtualization. There is a concept of desktop virtualization, where we see that a desktop is an important component of it is not the physical monitor, but it is the user experience of the desktop that can be virtualized, and like this many other parts of the component, partially or fully, can be virtualized. So, this is our machine where we have the hardware, we have the operating system on top of that, and then we have the application. When we virtualize, as we already have seen, that on top of the hardware, the virtualization layer, or this is called hypervisor or VMM, depending on the environment, that layer comes, and on top of that, rather than only the application, we bring in a combination of application and ways that the application wants a specific operating system. Along with that, we have a virtualized hardware components. So, this combination is called a virtual machine or VM. This is a one VM and the other is the other VM. So, number of such VMs can be brought in. So, the specific software layer on top of the hardware is called the is the main object that virtualizes, that will be used by the virtual machines for exclusive purpose. So, the virtualization layer will separate out, it can be looked at like it can separate out small portions of the hardware, and this small portion will be exclusively used by a virtual machine. It can be implemented at various levels in the machine. For example, we can do it at the instruction set architecture or ISA level, we can do it at the HAL level, we can do it at the OS level, and so on. Now, we will look at the various layers where the virtualization in a host machine is possible. So, at the lowest level, we have the instruction set architecture level. The ISA, as we said, is the topmost layer of the hardware of a system, and we can virtualize that. On top of that, we can do a HAL, hardware abstraction layer, that is not the ISA, but above ISA, which behaves, which gives the incoming process or the application a hardware like feeling that it is running on. We can do it operating system layer, operating system level virtualization, where we virtualize the OS layer. If we go above, we have the libraries that are being accessed by various applications of a certain language, of a certain compiler. We can virtualize that. Even at the top, there is application layer virtualization. So, all these, let us look at the details of these. First, we look at the application level virtualization. This is the process VM, as we will see a little later. This is the application level virtualization. This is typically this creates a process, separate process for applications. JVM or the .NET CLR are typical examples of this, by which Java Virtual Machine is a mechanism using which Java program can be ported to various architectures, various hardwares without any problem. So, therefore, the platform independence is brought into Java because of this. .NET CLR also is a similar mechanism. At library level, the user level library API is virtualized. These API hooks on to the operating system, and therefore, they behave between different types of between applications and the rest of the system. They create a communication between these two. Wine and vcode are examples of this library level virtualization. In the operating system, we create an abstraction between a traditional operating system and the application. So, the OS creates a container of its own and the applications are run in that. This is a very common way of doing virtualization, which does not go down beyond OS operating system. So, my hardware, the ISA, all these are kept intact, and on top of that OS containers are created and virtualization happens. These containers are like a server to the application. To the application, it is completely transparent and they behave like a server. Jail is an example. Virtual environment are examples of such virtualization. Then comes perhaps the most popular virtualization, which is the hardware abstraction layer virtualization or HAL level virtualization. This virtualizes the hardware, the processor, the memory, the IO devices, this whole bunch of components that are our hardware contains, our machine contains, all these are virtualized. By virtualizing this, we can improve the usage of the hardware, especially the processor. Zen and VMware are examples of that. Last but not the least in this list of machine level virtualization is the ISA virtualization. This typically the problem happens is that many times we create a process, we compile a program for a specific ISA, but in case that ISA is not available, we want to run it on another ISA. At that point in time, the ISA level virtualization basically it emulates one ISA, emulates the behavior of another ISA. QEMU and Dynamo are the such examples of such virtualization. Besides the machine level virtualization, we have network virtualization, where the whole of the networking, the hardware components and the behavior of the network are virtualized. That is called a virtual network, and this whole all components put together, the functionalities are provided in software. We will discuss network virtualization in details in a later module. Similarly, storage virtualization, since storage is such an important component in our computer, that virtualizing storage becomes very important. It's not only important part, it's a very complicated mechanism to be able to understand how the storage behaves or how to access a specific area of storage. So, the location which way the storage is organized and how to access a specific location, all these can be abstracted away from the users by a storage virtualization. So, instead of the physical disk or the physical storage, a logical view can be provided by means of virtualization. And this way another advantage happens that if there are different storage mechanisms that is being used by a user, the user does not have to learn the different mechanisms. One virtualization layer with a specific logical view can be created. We will talk about storage virtualization later. There are many other virtualizations, as we mentioned, desktop virtualization, all I/O devices can be virtualized, so I/O virtualization and others. But in this module we will concentrate on the hardware virtualization or the HAL level virtualization. So, for hardware virtualization, the idea is perhaps the oldest. All other virtualizations came after that. Around 60s the concept of virtualization has been conceived. In 1972 IBM introduced their system with a virtualization, virtual machine operating system they came up with. The idea stopped for some time after that, but with the advent of cloud computing, the concept of virtualization came back very strongly and it is being used very popularly. Now, the current version of or one very popular mechanism is called the virtual machine monitor, VMM, or hypervisor. This hypervisor is run in the system and helps virtualize the hardware HAL level, which means the all the hardware underlying the ISA will be virtualized using this mechanism. The typical layering of hardware, the OS, the hardware, OS and then application is modified with another layer of virtualization. That is how we typically visualize virtualization. So, before we get into that, let us look at the terminologies that we are going to use. We will use the term VMM or hypervisor. This is the software layer put somewhere in the machine to abstract away the rest of the existence of other components. We will use guest OS. So, the above virtualized layer, above VMM, the virtual machines will run. Each of these virtual machines will have one specific operating system. These operating systems are called guest operating system because they are not the primary operating system in the system anymore in this kind of virtualization. We also have the concept of host OS, where this operating system is the original operating system. It is not a VMM or not created for the purpose of virtualization, but we sometimes we virtualize by maintaining the host OS and implement the VMM above it. At that time we call this particular operating system a host operating system. In a certain kind of virtualized environment, this is visible. So, we come to the concept of VMM or virtual machine monitor. The requirement is that we add one additional layer above the hardware. This layer is called virtual machine monitor or VMM. This is the piece of software that provides the abstraction to the virtual machines. This is also called a hypervisor. Now, there are two types of virtual environments that we can create. One is a 3-layer architecture, which is called a type 1 hypervisor, where we have the hardware as the last layer. On top of that we have the virtual machine monitor or virtualization layer and the guest environment. This guest environment will have the application, will have the guest OS and has the virtual hardware. Now, how does this look? This looks like this. So, this is our hardware, this is our hypervisor, and each of these virtual machines will have an application, will have its own operating system, and will have a set of virtual hardware. So, any number of virtual machines can be run on this kind of environment, and in each of these virtual machines we can run a separate operating system. So, since VMM is installed on top of the hardware, this also is called type 1 is also called a bare metal hypervisor. The guest OS will be installed on top of the VMM. Therefore, obviously guest OS does not have the complete privilege that normally it enjoys when it is installed on top of the hardware. Therefore, the applications and the guest OSs have to make some kind of modifications. We will talk about that. The privilege level of the OS will be emulated by the VMM. All the privileges that OS enjoys will have to be emulated by the virtual machine monitor. Xen and VMware ESX are typical examples of a type 1 virtualization. If it is not type 1, then we talk about type 2. In type 2, the problem of type 1 is that many times it is hard to implement to remove the operating system, install a VMM on the bare metal. So, type 1 implementing type 1 and using type 1 may not be simple. So, we use for convenience we use the type 2 hardware, type 2 virtualization, which is the hosted virtualization. It is easier to install. So, this is called hosted because there is a host operating system underneath the VMM. So, the hosted in hosted the VMM uses the functionalities of the operating system already installed as the host operating system. Since the basic operating system remains in place and we do not disturb this, type 2 can accommodate a lot of various different configurations. QEMU and VirtualBox are typical very popular examples of type 2 virtualizer. So, in type 2 there will be 4 layers, already the 3 layers hardware, VMM and the application guest environment is there. Now, in between the hardware and the virtual layer, the host OS will be implemented. So, this is how it will look. We have the hardware, host OS, hypervisor and VMs, virtual machines, but since there is a host OS underlying on top of the hardware, the applications that are native to this operating system can also be run. Instead of having type 1 or type 2, we can have a hybrid. Always the type 1 is not easy to implement, type 2 does not show the proper cannot take advantage of having a virtualization layer. So, therefore, what is desirable is that VMM should run at the highest privilege level. So, this is done by using a hybrid model. In hybrid model, the VMM shares hardware with the host operating system. We keep the host operating system and also the VMM through kernel extensions and device drivers. This can be implemented. So, this is how it will look like. We have the hardware and we have the hypervisor running on top of the hardware. We have a host operating system also running on top of the hardware. The host operating system runs the native applications directly on top of them with full control on the hardware. Similarly, the hypervisor runs the virtual machines, and these virtual machines will have their guest operating systems inside each of the VMs, and they will be running at a lesser privilege mode. So, now let us look at the virtual machines. The guest operating system and applications plus of course the the virtual hardware will consist of a virtual machine. The VMs are capable of virtualizing a full set of hardware resources. Every VM, every application running inside a VM will feel that a complete hardware set is dedicated to that particular application, or at least that particular virtual machine. There will be two types of such virtual machines. One is called the process VM and the other is called the system VM. So, this is our process VM, where we have the hardware, we have the operating system and the virtualizing software and the application process. So, virtual machine will consist of this whole thing and application will run on top. So, this virtualizing software translates instructions from one platform to another. So, it is possible to have this is a platform independent architecture. This is the JVM concept of the process VM. This will be useful for executing a program which is compiled for one operating system and port it to another operating system, or even a different instruction set architecture. The VMs are part of the guest process. As soon as the process terminates, the VM also terminates. The other type of VM are the system virtual machines or system VMs. Here we have the hardware and we have the virtualization software on top of it, and we have the virtual OS and the applications. So, here it provides a complete system environment. The OS user process, the networking, I/O, display, the graphics user interface, everything will be included in part of that. The guest OS is part of the host. So, the machine that are being run, the applications that are being run, accordingly it will be executed. So, the system level virtual machines are the multi-programming concept. They provide the illusion of a complete system and supports multiple system images simultaneously. Each image runs its own operating system as the virtual machines, and these operating systems will control their set of virtual hardware. This is the virtual hardware that will be controlled by these VMs. So, the real resources of the host platform will be actually, in effect it will be shared, but it will not be visible to the applications. The virtual machine monitor or the hypervisor will be taking care of that. It manages the allocation, access, the privileges of the hardware. Although it is owned by the VMM, the feel of the application is that the corresponding guest operating system is controlling it. The VMM decides the share, which OS should get, which guest OS should obtain, how much of the physical hardware will be decided. The guest OSs will be alternately scheduled. Essentially, the guest OSs will be scheduled in a certain fashion, so that each guest OS gets the feeling that they are running for a long time. Therefore, it is an illusion. So, now let us look at the virtual machine primitive operations. There can be basically 4 primitive operations. We can multiplex virtual machines, we can suspend a virtual machine, we can provision a virtual machine on a hardware, and we can migrate a virtual machine. So, this is a multiplexing of a VM. We see that there is one VMM on top of a specific hardware. If we look at this carefully, there are actually 2 machines. One is this machine and the other is this machine. They are both sharing a specific storage. Now, this particular machine having 2 virtual machine, this one and this one, they are both sharing through the VMM this hardware and the complete storage. So, that's why it is called a multiplexing of. So, 2 hardware, 2 machines can be made to share a storage, and this sharing will be completely transparent to the applications running on top of the VMM. So, this is called multiplexing. Now, any VM can be stored in the storage through the help of the VMM and the hardware. The VM goes to a storage without any problem. Now, provisioning will be that suspended VM can be provisioned in another hardware very easily. That is, this is a power of virtualization. So, VMs can be easily provisioned to the next platform that is available. Therefore, bringing this VM that was running here to here can be done. One way of doing it is I suspend it, store it in the storage, and then I provision it to the other hardware. Easily it can be done, or we can even migrate the VMs to another platform. Easily a VM can be migrated. VM migration is a very useful mechanism that is given to a cloud environment by the virtualizing mechanism. Now, what are the benefits? Let us look at the specific benefits. The interfaces will be familiar. I have a specific way of looking at it, a specific operating system to work with. Always in a virtualized environment, I really do not need to worry about what my hardware or my machine is offering. I can work with my comfortable hardware operating system. Flexibility of applications. Since there are many operating systems that can be run on the same machine, therefore, different people may prefer to have different operating systems to work with, and all that can be run on a specific hardware. And security, since VMs are isolated applications, therefore, to a large extent security is provided. And of course, server consolidation. By suspension, provisioning and migration, all servers can be consolidated and may be looked as one particular hardware. High availability, we can save the VM, run it once more, and we can do migration, and no failure is really important, and environment is simplified. There is high scalability and fast recovery, backup can be possible. So, to summarize the session, we have looked at the types of virtualization. We saw the types of VMs, and we looked at the virtual machine monitor types and the primitive operations of the virtual machine, followed by the benefits of VM. We will continue our discussion on the virtualization, and in the next class we will look at what is the virtualizability of a specific hardware and the Popek-Goldberg theorem that is important in virtualization. These are our references. Thank you.